to get those irrational decimals that don't repeat, we have things like square root of 2, square root of 57. Those are all irrational. They don't repeat. They're just crazy decimals. That word means to some of us crazy, right? If someone's behaving irrationally, they're acting crazy. Pi and E are also on that list of crazy irrational decimals. So I have this cute little chart that relates all these. I don't know where they get these Z is integers and Q is rational, okay? I know they can't use R as rational because these are all real numbers and we use R for rational. But this shows that the naturals all fall within the whole numbers, which all fall within the integers, which all fall within the rational numbers. And then there's this little subset over here of irrational, crazy numbers, and those are all real. And then if we add in non-real, then we get complex, imaginary, and all that good stuff. Any questions? Kind of remember this? So be careful. If I said square root of 25, which number groups does that fall in? Yes, all of them except for irrational. Whereas if I said square root of 7, that is irrational. This one's just in disguise, right? It's 5, and so it's all of them. Okay. When you describe subsets of numbers, there's two ways that the book talks about it. It talks about a set builder notation, and I'm going to show you what that looks like because they use it on standardized tests once in a while, but it's horribly confusing. So we're just going to use interval notation. Everybody remember interval notation? Okay, so we're going to use interval notation with the little infinities and the parentheses and the hard brackets. Okay, so here's an example. If we said x is greater than 18, this is what it would look like in set builder notation. This is read x such that x is greater than 18, where x is an element of the real numbers. Okay, I agree. But if you ever see this on a test or quiz, just ignore everything except this little middle part right in here that says greater than 18, okay? The rest of it doesn't mean anything. I mean, I guess it could if it said that it wasn't a real number, if it said it was like where x is a set of the integers only or something, then you'd have to think about it a little bit. Interval notation is what we're going to stick with, okay? This just means 18 and greater, right? 18 to infinity. So it means the same thing. X is greater than 18. This parenthesis means that we're not including 18. One more time at the bottom is one more example of set builder notation. The set of numbers x such that x has the properties of being between -3 and 16 inclusive, where x is an element of, and this says z. What's z, guys? Integers. So anybody know what integers would fall in between there? We'd include -3 and 18 because of the or equal to's, right? Yeah, oh, it's 16. Thank you, bifocals. -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay? So there is a finite number of answers to that because it's the integers. Don't worry about it. We're just going to do real numbers and we're going to do this notation. Does everybody remember this? Anybody not familiar with this? Okay? I like to talk about it as number line. If we had this open circle going this way from like -4, then we had a solid circle at -2 to 0, and then we had something crazy like an open circle at 7 and going up. That's about as complicated as it could possibly get, okay? You would say left to right is the way you do it, least to greatest. You would say -infinity up to -4 with a parenthesis because of the open circle. And do you remember this crazy U for union of? This would be a hard bracket, -2 to 0. Does that seem right? And then we'd have 7 to infinity. You're not going to have something like that right now, but I'm just trying to, does that kind of refresh your memory about all the crazy business? And it should be written least to greatest. This chart is right out of the book if you have trouble. You got what you want, Riley? Okay. Whoop, did I go the wrong way? All right, so let's practice real quick. Anybody, how do we write x is less than or equal to -2 in interval notation? If we were doing a number line, we'd have -2 this way, but we have to start at the left side of that. So what do? Yeah, the hard bracket because of the or equal to. The infinities always have the soft, right? Because I just think of it as infinity doesn't ever end. It's kind of just. All right, what about number 2? If we drew this one, we'd have like an open circle going this way, which correlates to a parenthesis. That is so hard for me to write because my 8s and my infinities are just like, anybody else have trouble writing that one? Here, 8 wanted to fall over and become an infinity. Sorry. All right, number 3. It really just looks like an ordered pair, right? Because this means x is between 5 and 15. If you graphed it, you would have an open circle here and an open circle here and in between. X is less than 15 but greater than 5. I call that one a sandwich sentence when it's sandwiched in between. And this guy, this is the icky one. -infinity to -11, both soft, okay? Okay, take a second and look. Did Katie get it right? Going that way from -1 or -11. It includes 1 and up. How'd she do? -infinity to -11, 1 to infinity. We good? All right. Function and relation. Anybody? There used to be a what is that? Schoolhouse Rock that had a function junction. I don't know. Anyway, we'll have to look up YouTube for fun. A relation is a rule that relates or pairs the elements in set A with elements in set B. So anytime you're doing something that pairs up something, it's a relation. It's only a function, though, if it assigns each element in set A, or the domain, to exactly one element in set B, or the range. Okay. Set A contains the inputs, or the domain, which are the x values. Set B is the outputs, or the range, which are the y values. This all sound familiar? All right, so the y is the dependent variable. It depends on what we put in for the x. We pick an x, we put it in, and we find the y depending on what we picked for an x. All right, so does this work? That would say 2, 5, 3, 5, and 4, 6. Right? if I plotted those over 2 up 5, over 3 up 5, over 4 up 6, what do you think? That's a function, right? Can you give me one that's not a function? What if it does this? 2, 4 is an ordered pair, and so is 2, 6. That's a fail, right? Because if I plot it over 2 up 4, over 2 up 6, they line up vertically. Do you remember the vertical line test? Now it's coming back to you, okay? The x's can't repeat, okay? The x's can't repeat. If you have x assigned to 2 different y values, it doesn't work. That's out of your book. It's called the vertical line test when that we're going to talk about here. I just want to show you a feature of the book. And this is a horribly boring little video, but I want to show you a couple features of the textbook. So I put this, you should be able to get into this, okay? The website, the login, has anybody tried? It's on the back of the syllabus with all the information you needed. I have an extra copy if anybody needs one. But when you get logged in, then you'll go to the student edition, you go to the ebook here, but first it'll go directly to it if you pick chapter 1, section 1, and then you click on the ebook. But when you get the ebook opened to section 1, at the bottom it lists a bunch of little features. This particular section has an animation. It's really exciting, let me tell you. Okay, but it also, I wanted to show you this little check mark at the very bottom. Does everybody see where I'm pointing down here? Okay, it's like a little quiz. It's like a little practice, and come on. It brings up 5 or 6, I can't remember, multiple choice questions that could be asked from this section. Then you pick your answers. There's hints if you want to see your answers, etc. Okay? Then you go to the bottom and you say check it. And it will tell you not only what the right answer was, but it'll also tell you what example to look at on what page, okay? Now, I will tell you right now that I already found a mistake on one of the problems, so I'm not 100% happy, and it's not one that's listed here. And that's what I was going to say as well. You can say try again down here, and it'll give you more questions, and they're not the same ones. I don't think there's infinite questions on this section, but there's more than one set, okay? So that's good practice, like the night before a quiz or test, covers these 4 sections. Go back through and look at them. What I wanted to talk about was, okay, gotta go back to this window, I think. Nope. It also, if you care, yeah, I'm gonna look at the animation, but if you care, down here at the bottom of the page, if anybody is really, really auditory, at the bottom of the page, it has this little guy. It'll read you the text.
Look back. You can review set notation, including
I'd fall asleep if I tried to listen to him, but
in lesson.
All right, so it'll read you the textbook. Finally, here's the little animation I wanted to show you. It's on the vertical line test, in case anyone doesn't remember what it is, but there's one good example.
Use the vertical line test. The vertical line never intersects the graph at more than one point. So this graph is a function. Is this a function? Use the vertical line test. The vertical line intersects the graph at more than one point. So this graph is not a function. Is this a function?
This is the one I want to show you.
Use the vertical line test. Notice that at the y-axis, the point on the axis is included for the lower portion of the graph, but not included for the upper portion of the graph. The vertical line never intersects the graph at more than one point. So this graph is a function.
Everybody okay with that one being a function? Oh my goodness. She makes me fall. I mean, I could like fall asleep in like 2 examples of her reading that thing to me. She's really bad. All right. Anybody awake? No. Okay. Let's try to answer our questions and re-engage ourselves here. Is this one a function? Yes, none of the x's repeat. A couple of the y repeats, but the x's don't. What about this one? I don't know if you have this or not. This one had the parabola here crosses, a vertical line will cross it more than once, so it's no. What about that one? There are some with no graph on the homework and or a test, and they're rather hard to graph. If you want to graph this on your calculator, you'd have to get the y by itself, right? So you'd have y squared equals 5 plus 2x, and then you'd square root, but what would you have to remember? Yes, and when you graph that, you would get 2 pieces, okay? So this is a no. Generally, anything that has a y squared is going to be a no. Let me talk you through that. If I put in, say, a 2 here, this would say y squared minus 4 equals 5. I add that over there, I get y squared equals 9, right? Y equals plus or minus 3. Are you good with that? Okay, I put in a 2, and I got out a 3 or a negative 3. You see where that would be a problem? Okay? So the y squared indicates that it's not going to be a function. Now there's also a word problem on the homework or two that says something like this. I struggle with these myself because it says the input value of x is a student's ID number and the output value y is the student's score on a physics exam. Is this a function? Is y a function of x? Okay. Student ID numbers don't repeat. They're unique. So they say yes, it's a function. My issue with this is I want to know, well, what's the rule that relates one to the other, right? There's no rule that says if you have this ID, you're going to get this score. But it doesn't repeat, so there's some kind of assigned value, so they call it a function. All right, you have this in your notes, I think?
Yeah.
Example 1, can you tell me how I might draw something that is a function? Okay, a parabola that opens this way. What about a line? Any line except a vertical line. All right, B says draw a graph that's not a function. Okay, a sideways parabola, a circle, a vertical line. Okay. Example 2. Everybody good? Example 2 is this one, and I did it because I needed a little more room. This was on the pretest, and it was like one of the only questions that almost everybody tried. Put a value into a function, you're good with this, right? Be really careful because the signs can mess you up. Can you type this one in and see what you get? I believe that's right. Is anybody not getting negative 172? Everybody okay? The parenthesis that'll mess you up if you leave it off is this guy, right? Negative 4 quantity squared should be positive 16. Everybody good? All right. When you put in a 2a, you're putting it in everywhere that there was an x here. So you're going to have 4 times 2a cubed plus 6 times 2a squared plus 3 times 2a. And we're in Precalc, so I'm afraid I'm not going to let you slack by just stopping there. Okay? You got to simplify this. 2a quantity cubed becomes what? 8a cubed. And then there's still that 4 out there, so we're going to get a 32a cubed. 2a squared would be 2 times 2a times 2a would be 4a squared, times 6 would be 24a squared. And back here, 3 times 2a would just be 6a. Now, are those any of those like terms? No. So it cannot be simplified. Some of you are struggling with the idea that we could factor something out, but it doesn't ask us to factor. So this is as simple as it gets. Okay? We're used to thinking we should factor things out because we want to solve something. This is simplified form right here. Any questions on that? All right. This is called a piecewise function. And we're going to work on graphing those tomorrow, so that will be tomorrow's horror. Today, we're just going to plug in values, so there's no terror involved. It says if x, this is the definition of g. It's got 3 parts. If x is less than or equal to 4, this is the rule. If x is between 4 and 10, this is the rule. If x happens to be 10 or greater, this is the rule. Everybody good? So if I put in a 1, where do I put it? It's less than 4, so I put it in this one. And if you leave that answer, I'm going to write a big old frowny face, because the square root of 1 is 1 plus 1 is 2. This is my favorite answer ever. On a semester exam in Precalc, I was like, oh my goodness. Kind of scary. It's just 6. Okay. Put it a 3. Where are we going to put the 3? Still less than 4. So we get square root of 3 plus 1, which doesn't simplify. We could get a decimal approximation, but I would just leave it. Okay. What about 6? Between here, so we'd have the rule is 3 times 6, or 18. Everybody good? Did I lose anybody? All right, what about 10? Exactly 10 has to go in this one because of the or equal to. So when we put a 10 in there, we get what? 185. Because you square it, then multiply by 2, then subtract. We're all good? Okay. A little more practice at this, and then we need to talk about domain and range. Can anybody put in a -1 here? Carefully. What do we get? I got 10. What happens if you put a 2x in? How does that simplify down? Okay. Now, this is the one that people struggle with because they want to take shortcuts. X plus 8 squared minus 8 times x plus 8 plus 1. Is this x squared plus 16? No. Is it x squared plus 64? No. X plus 8 times x plus 8 is x squared plus an 8x plus another 8x, which you might as well write out if it's a problem for you. 8 times 8 is 64. Then we have the rest of this back here. I'm going to distribute this. We have minus 8x minus 64, and then the very back was a plus 1. Remember, that all came from up here. What does that mess simplify to then? Okay, one of these were knocked out. Everybody good? Sorry, kind of scribbled on that one. Okay, Tyseer? Got it? All right. Anybody do these real fast? What happens if we put in a 3? Which rule does it go in? The second one, because it has the or equal to. So f of 3 would be 2 times 3 plus 10, or 16. What about 8.5? 8.5 goes in this one, and there's no rule, right? It just says everything is just 42. It would be horizontal line. Yes. All right. So function or not a function? Number 7, input is the license plate number, output is car's make and model. Does this repeat? If we're going to be staying in Illinois, license plates, they're all unique, so we're going to go with this is a function. This is a function or not a function? It is a sine curve or a shifted cosine. Has an amplitude change. I don't know. But anyway, what's this one? Okay. That was easy. Now we got to talk domain and range. Okay, don't fall asleep. This is the hard part. Not really. Students think domain is really hard and tricky, but the bottom line is domain is all real numbers. Okay? Unless, 2 things. If there is a denominator with an x in it, that cannot equal 0, so that will place a restriction on your domain. If you have a radical, like a square root or a 4th root, it has to be positive. What's underneath must be greater than or equal to 0. That's it. Otherwise, there are no restrictions on domain. It's just all real numbers. Okay? If you have a cube root, there's no restriction. Everybody knows you can take a cube root of a negative number. Cube root of -8 would be -2. Does that seem okay? Because negative, okay? Otherwise, it's all real numbers. So let's look at this example. This has a denominator, so there's a restriction because it has an x down here. Whatever is in the denominator cannot equal 0. If I factor out an x, what 2 values would make this 0 so they are restricted? X can't equal 0, right? And it cannot equal, if I solve that over there, I'd have 6. In interval notation, I would say everything from -infinity to 0, everything from 0 to 6, and everything from 6 to infinity. Now, students struggle sometimes. The fact I've written 0 twice, it isn't included in either one of those, right? Soft on both ends. So this means x cannot equal 0, x cannot equal 6. So sometimes later on we will write all real numbers except x cannot be 0 or 6. But in interval notation, this is what it would look like. I'm just going to do one more question. Y equals, if I move this over, I get that. Domain and range. Is this a function? Yes, it's a line, right? So what is the domain and range? Yes. That line does not stop going left, right, or up, or down. Okay. We will pick up with number 11. We're almost done with the notes, and then there's another section of notes on this same assignment on Piecewise tomorrow. Okay?